So what is this, Tia, by the way? I just saw you have a poster here. Is it your birthday then? It is. Okay. So do we want to sing happy birthday then? Just real quick before we start talking about ionic bonding. Okay, let's do it. 3, 2, 1. Happy birthday to you. Happy birthday to you. Happy birthday, dear Tia. Happy birthday to you. Happy birthday. Okay, now let's do some chemistry. So you remember last time we talked about positive and negative ions? Do you remember? Yes. You took those lovely notes. Okay, so how are the positive ions called? What? Yes, what, Kaylee? Cat ions. Is she the only one that remembers that?
No, I don't.
No, okay. So cat ions are positive. What's the name of the negative ones? Louder. Anions. There you go. So these are positively charged. These are negatively charged, right? Okay. So now, of course, I said last time, right? We're setting the stage. What do these things do? They bond. Make sense? So one loses the electron, becomes the cation, right? Positively charged. One gains the electron, becomes negatively charged, it's an anion, and they attract each other. There you go, right? So if you look at it, so this is a block of salt, okay, from a mine in Carlsbad, I believe. That's what Miss Borita told me. So this is salt, right? NaCl, salt, kitchen salt. This would be a model, a molecular model of salt. So do you see what happens here? The little red balls are actually the cations, the positively charged ones. In fact, the radius of an atom decreases, right, when it becomes a cation, okay? And the negatively charged, they are the white ones, right? So this is what happens. They form a crystal. I know that you like the way I say crystal because I roll my R, don't I, Jenny? Anyway, so they form these crystals, salt. You are very familiar with salt, right? And you know the properties of salt. Like if I get this block of salt and I just like hit it with a hammer, what's gonna happen? What do you think is gonna break? It's gonna break. It's gonna shatter, right? So they're not like metals, right? You know, you remember what did we say? What were metals? The properties of metals. Okay, conduct electricity, but then what else, Tara? Malleable, and the other word, ductile. So if I do hammer a metal, it won't break, right? I can deform a metal, makes sense. I can like make it really flat. I can stretch it, right? But I can't do that with an ionic compound. Why? Because you see how all the ions are like kept in place, right? You know, they have like very specific positions. The electrons are not delocalized. So if I just like hit it, it will break, right, apart. So what is an ionic bonding? So I did the review already, right? Cation, positive charge, usually elements with low ionization energy. They are metals, right? Group 1 loses 1, group 2 loses 2, group 13 loses 3. Anion, negatively charged, right? Now, this is what happens. You could write something down in your evidence notebook, right? So what happens in ionic bonds? Like the NaCl, the Na plus 1 and the Cl minus 1 just like attract each other now, right? Because one has lost an electron, do you see? You remember we talked about electron dot structure, right, at the end of last class? So Na has got 1 valence electron, right? Chlorine has 7 valence electrons. So it works out really well, right? Chlorine sort of grabs that electron from the sodium, right? So they both will have an, what kind of configuration is this stable configuration? How is it called? the one of the noble gases. How many valence electrons? 8. So how is it called? Octet, right? At that point, both of them will have the octet, okay? And they will just form this, okay? So there won't be just one and one. Do you see how it is? It's not just one sodium atom and one chlorine atom, right? But there is a lot of them, and each one is surrounded by many, each cation is surrounded by many anions, and each anion is surrounded by many cations, okay? All right. So does it make sense with the electron dot structure? These are the electron configurations, right? Sodium is 3s1, chlorine is 3s2, 3p5. Bam, what will happen is that they will both become what? They will both become a 2p6, right? Well, no, sorry. Sodium will become a 2p6 and chlorine will become a 3p6, right? So one will become neon and one will become argon. A part that they want, just the electronic configuration, right? Are you up for this? So the resulting compound is neutral, right? So an ionic compound is made of anions and cations that are like attracted to each other, but the compound per se is neutral. Salt is neutral, right? You know that. It's not electrically charged, right? It's just neutral, okay? Because you have so many positive charges, so the number of positive cations equals the number of negative anions, right? So the compound is neutral. There you go. Huh? This is an ionic compound. Inside this, there are like trillions of sodium cations and chlorine anions. Make sense? Yes? Okay. I move on, right? Now, the reason why we are gonna play around with our little baggies here, right? And try and combine different cations with different anions, is that when I have a cation like magnesium that has two positive charges rather than just one, right? So how many chlorines do I need to get those two electrons? Because each chlorine will only get one, right? I'm not going to get a chlorine atom that's going to gain two electrons. Makes sense? Chlorine will only gain one. Then it's happy. Then it's a noble gas. It won't gain another electron. So how many chlorine do I need to bond with one magnesium cation? It's clearly there. How many? How many chlorine do I have? Yes, say out loud, 2. 2. So, while the formula of sodium chloride is NaCl, the formula of magnesium chloride will not be MgCl, but will be MgCl2. This is the whole point. That's why we're going to play with that, because this is kind of like not super easy to get. But you see what I mean? The formula unit for magnesium chloride is not going to be MgCl. It's going to be MgCl2, okay? So for each magnesium, I need 2 chlorines. Do you understand why? Because magnesium will lose 2 electrons, right? And so I need 2 chlorine atoms to grab. One will grab one, and the other one will grab the other one, right? So that's why we're going to like try, and that won't be very easy, right, to figure out. But you will kind of get used to it, right? Because you know that group 1 loses 1. Or if you don't know, you will know, right? So group 2 loses 2, group 3 loses 3, and then you know that 15, 16, and 17, they gain, right? Because they're non-metals. They gain either 3, 2, or 1, okay? So we continue with the ionic bonding. So that's the trick, right? The trick is that it won't always be a formula unit of 1 to 1. The ratio will not always be 1 to 1 between the cation and the anion, right, Ron? Sometimes the ratio will be 2 to 1. Sometimes the ratio will be 3 to 2, right? Depending on how many positive charges the cation is like losing, or how many electrons the cation is losing, and how many electrons the anion is gaining, okay? To be neutral, and we still want the compound to be neutral, right? So to be neutral, you need 2 chlorines to balance the 1 magnesium, okay? Formula MgCl2, okay? And that's something that will take some time, but we will get there. Okay, can I go on? No? So you see how the magnesium has 2 valence electrons, guys? Remember, right? There you go, S2. All group 2, they're all S2s, right? 1s2, 2s2. Well, not 1s2, because 1s2 would be helium, right? And helium is a noble gas. But 2s2, 3s2, and so on and so forth. Chlorine, 7. There you go. So you need 1 chlorine to get each one, to get each one of the magnesium, of the electrons that the magnesium is contributing, okay? And so to be neutral, the formula will have to be MgCl2, okay? Now, the properties. I'll just go over it. So, first of all, the characteristics of anionic compounds. We kind of said that, you know that, right, Cooper? It's always a metal plus a non-metal. Why? Because the metals become cations and the non-metals become anions, right? So it will always be a metal and a non-metal, they form an ionic compound. The ionic compounds are salts. Guys, there's not only the salt that we use to salt the water of our pasta, you know that, right? There are thousands of salts, right? Especially if we start to look also into the polyatomic anions, we get there, okay? Right now, let's just look at monoatomic anions, okay? So there's not only NaCl, sodium chloride. I know that we always think that salt is sodium chloride, and it is, but there are many other salts, right? Potassium chloride, sodium bromide, lithium fluoride. By the way, can you recognize something I'm saying? How do these all sorts of names end in "ide"? Thank you very much. So they all end, if the anion is monatomic, the names will all end in "ide", I-D-E, okay? So we change. So we will not say sodium chlorine, right? We won't. We will say sodium chloride. So you change whatever, you get the stem of the name of the atom, and then you put "ide", okay? They have very high melting points. Hint, hint, we're gonna try and melt salt and sugar. Which one do you think is gonna melt sooner? I know that you know that because you cook, right? But yes, it will be sugar. So ionic compounds, or you watch your mom cook maybe, or something, right? But anyway, so yes, they have very high melting points because the ionic bonds are very strong. I think I will have to close that door. What do you think, guys?
I agree.
Do you agree? Okay, because I don't know what's going on in the hall. But it's not really helping me, is it? Eh? They're doing some sort of like activity. Okay, now, and the other characteristics, oops, okay, the other one, so this is the last thing, okay? Like, they will not conduct electricity like this, right? But if I dissolve it in water, if I dissolve salt in water, I form an electrolyte solution. Like, for example, in batteries, that's what it is. Batteries are like electrolytes, right? So you have some sort of like ionic compound dissolved. Usually it's not really in a liquid, it's in a paste, right? In the liquid batteries, but it's sort of liquid. So still the ions have the freedom to move, right? And so whenever do you have freely moving charges like electrons or ions, cations and anions, you can conduct electricity. Did you do that in physics last year, right? You know when electricity flows, when there are some freely moving charges there, right? Either electrons, which are negatively charged, or in this case you can have cations and anions. Here you don't have free electrons, right? The electrons are not free. You have them very localized on the sodium and on the chlorine, I mean on the anion and on the cation. But the ions are either positively or negatively charged, right? Okay. And then they form this 3D structure, okay? 3D crystal structure. There you go. These are our lovely ionic compounds. So now, did you all pick up the handout? Cameron, can I use yours? Ionic versus molecular. Now, molecular is another name that you will hear when we refer to covalent, right? So hey, I wrote this down here for a reason, right? So this guy, kitchen salt, it's ionic. We just said it, right? So that C didn't come out very pretty. Sugar, this is the formula for sugar, for sucrose. There are a lot of different sugars, like glucose, fructose. The regular sugar usually is sucrose. The formula is C12H22O11. Do you see already like how different these things are, right? So this is just one cation and one anion, right? Of course, I don't have just one and one, you know. I have a crystal lattice of like, you know, a lot of them, right? But this is the formula unit for sucrose, and this is called either, you'll hear that this is either a molecular compound or covalent. Covalent, which means the bond, the kind of bonds are not ionic, but covalent, okay? And we'll talk about that. But anyway, let's look at this, and then we'll go to the lab and have fun, okay? So do you all have it? So what's the purpose here, the objective? To observe the melting of sodium chloride and sucrose. There you go. To compile a list of characteristics describing sodium chloride and sucrose that could be used to help identify them. Namely, one melts sooner than the other, right? So, hint, hint, if people give you two powders and tell you, like, you know, you become a chemist, you have your own lab, they say, hey, I have these two powders. Let's not comment about powders, please, here. But would you tell me which one is a sugar and which one is molecular and which one is ionic or something, right? A very simple thing you could do is try and melt them, right? And see which one melts sooner, okay? Now that seems like, like naive, but it's something that like chemists do pretty much, right? So we go back, we will wear goggles. And we will be careful because hot plates get hot. That's why they are called hot plates, right? We will. Thank you. And so you will turn on the hot plate. There is one hot plate at each station. You'll share it, okay? You will wear safety goggles, okay? And then what you're gonna do is just that you're gonna try and make a little container with aluminum foil. He calls it boat here. You can shape it as a boat. It doesn't have to be shaped like a boat, right? You know, just a little container of aluminum. And put a few crystals of salt and a few crystals of sugar, right? That everything is on the table. You put it on the hot plate, right? And you observe what happens. And in the meantime, you complete this, right? So what are we bringing back to the lab area? We are bringing the handout and a pen / pencil, and we wear goggles because we love our eyes, right? Let's go. Oh, you are gonna be quick and efficient in forming 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. Huh? I am gonna put on the hot plates. Okay? Yes, please wear goggles. The aluminum foil is here.
It's weird.
Okay. It doesn't need to be a lot, right? Of this. Just a few to observe what happens. And just putting on the hot plate in this line. You go. So each table you are sharing one hot plate because I don't have enough, okay? It's okay. You can put 2 bowls. Or maybe you can do 1 bowl. That would work too, right? Right, Cameron? The goggles have to be on the eyes, not on the head. Thank you. There you go. Done. And the hot plates are hot, right? Cara and Julia and Brendan. So we're not touching them. Thank you. So no, you have either like tweezers or this if you wanna like when you pick up the little aluminum bowl. You can join any table. I mean, this is not really like something. It's more like observing something. So you could even do it in one big group if you want, or you can have each one of you can have their own table. I turn it on, so be careful, okay? It is gonna get hot. So you have the salt and sugar at each table, right? Did you see that? And yes. Well, what would you think? What are we looking at? We are looking at two things. One is salt and one is sugar. And we are looking at what? Which one melts sooner? So you could do like the two rows could be salt, sugar. The columns could be like, I don't know, observations. Because, you know, you might see something change color, for example, right? Or something like sizzle, I don't know, you know. So one could be observation and one could be like melting point or something, right? But you need to kind of start to think about your own tables, right, guys? You read the procedures, and the table is like a consequence of that procedure. Okay, yes, Jen. Okay, so you're gonna make the little boat with the aluminum foil, and then like boats. I don't know. They could be boats.
Like so it holds the sugar stuff.
Yeah. So it says aluminum boats for holding your samples of salt and sugar. Be sure to fold out the edges and have a good place to grasp it, right? Yeah. So aluminum foil. Do you want one? Boat and put like inside the boat you will put like your salt and a few pieces of sugar. But I do need you to know which one is the salt and which one is the sugar. Make sense? Yes. Okay. Do you want the boat?
I need my paper.
You need another paper? Make a boat.
Yeah.
Why are you looking at me? Make a boat. You want to do two boats or one boat? In this yeah. Oh, that's sorry, Cameron. You're right. Do you want to make two boats? One boat? One for the girls and one for the sugar. Okay. They don't have to be super. Two boats, one boat. How many boats? I'll give you the paper. Sorry about that. Yeah, that's a beautiful boat. Yeah. Sorry about getting your paper. You are the chosen one, see? Okay. Yeah, as long as you know which one is the right, guys? Yeah, you want to select both again? No, you will not know exactly. You can just say a qualitatively, so, you know, lower or higher. Lower or higher. Yeah, we don't have the, we are not actually measuring the temperature, okay? It's, it would
We're making two boats.
okay, that would be good. You do one for the salt and one for the sugar? Or just do like that group and this group? Huh? Would you ever thought you were gonna come to school and make sugar today? Huh?
Yeah, I
You knew it. Yeah. I know.
I'm gonna make a fat yacht.
Fat yacht. Do you guys want a little spatula maybe?
Well, are you ready?
If you guys, but you probably don't need it. Do you want a little spatula? We can use hands because these things are like non-toxic. But maybe we want to pretend we are chemists, right? Do you want a little spatula just to scoop out your salt and sugar? Are we making pretty boats?
More sugar.
Okay.
I can see the
You want a spatula? Yeah, as long as it, you know, as long as it holds a few pieces. You don't have to put a ton of it. It is isn't it?
No, it's fine. I'll probably be able to see the sugar once it.
You want it quite high because you want this to happen relatively quickly, right?
Smaller one
You're
is
gonna
salt,
stay here.
bigger one is sugar.
Guys, 8:30. We are not staying all morning here because then we are working with our puzzles. But
There you
come
go.
on,
There's
start
your
to
answer.
put them to melt. As they are, Ron, as they are on there, your eyes are like pinned on them. So you have to observe everything that happens, okay? Yeah. So you get the spatula, there you go. Spatula, there you go. You guys are already there, right? You can crank it up as well. Yeah, okay. You want a spatula to pick up the salt and sugar and crank it up because we want this to happen, okay? So, yeah. The goggles, where do they live? I know. I can already smell some melting sugar, I think. Can you smell it? So, you know, if you could see some observations of what's happening. Is it turning yellowish? It's melting. It's, you know, you need to fill in your little paper too, Mr. Bean.
I know, we do it a certain way.
Yeah, they have a lot. So do you want us to do a lot?
No, actually less. It's probably gonna be a bit faster, but you can move it a little bit. Yeah, look at that. What? Look, all those lovely observations. It's caramelizing, right? Isn't it? It's bubbling. It's turning yellow. Is anything? Yeah, that would work. Is anything happening to the salt? Yes, something. It's turning color too, but is it melting at all? No. Look at it. It's actually boiling. You see? Huh? The sugar, right? Guys, I know. What are you playing around? Really? Because you know, you are doing your work very well, right? There you go. So you're putting your boats on there with the salt and the sugar and waiting until and observing what's happening, right? Yes, time it takes. That's a good one. And then you can just do observations because you will see that a lot of things will happen. It will kind of like start to melt, then it will turn sort of yellow. You have tried it with sugar, right? Yeah. So okay. But hey, bambini, not tons of it. That's too much. Okay. Don't use all of it. I have 300. Cool. Okay. A few. Have you read a few crystals? Yeah, that's a lot too. Like that's okay. That's okay. Guys, are you observing or you're making your own? You should. Yeah, but after we are done, so maybe you want to. Yeah. Do you know? No, put them all together at the same time.
Okay, I think.
So did it start to bubble and melt and not yet? Is your hot plate working? Yeah. It's warm, hot, crank it up. Really want it to happen.
Well, did you touch it? Should we take this off?
I'm not gonna, no, don't touch it. I make me this favor, don't touch it. But you know, it should be pretty hot, okay? Guys, you know that originally this was supposed to be done with like candles, not hot plates. Can you imagine, right? Holding the boat over the candle. But we decided to change that. Okay, there you go. Changing color. Melting, right? So it's turning into a liquid. Before it was just a solid crystal. Now it's a liquid, it's yellow, it's boiling, it's smelling nice, lovely, right? Not really. Okay. Is it happening? Not really. It will happen. It's happening. Look at that. The sugar is giving us this lovely smell. Yes, Gabby. I'm here. You need to go to the nurse? Why? Okay, do you to have someone walk with you? No, you're good. Okay. So did you guys observe the sugar and salt? Yeah.
Oh, yeah.
I promise you that you can keep that salt on there for quite a while before they actually go to. I don't think you will be able to melt salt with a hot plate. That would be very dangerous. If we could reach that temperature with a hot plate, I think we will all go on fire. Yes. So, okay, go. I see you later. Are you gonna come back to the end of the cake? Yes, please. Okay. So we got it, right? What's happening? One is melting, one is not. But, guys, although this is something that you all knew, I bet you knew, right, that sugar was gonna melt and salt was not gonna melt, right? Because this is like stuff that we do every day in our lives. Now we know why, right? From a chemical point of view, Cooper, do we know why it's happening? Because what kind of compound is this that is not melting, the salt? What kind of bond does it have in it? No, that's ionic, right? And the one that melts, yeah, that's okay. It was 50-50, right? So, yeah. So that was called, that is an ionic bond. The salt doesn't melt. The sugar is covalent. I think that your hot plate is probably like, do I try?
Yeah.
No. Okay. It should have this.
Look at you,
So it should start, it's quite hot. So it should start, you don't do it with your hands. I know, I just, like, I've been in a lab for many years, so I don't trust it. Yes. If you were given 200 crystals and asked to classify them as either ionic
you can take it off.
what
Yeah, but
steps
we
would you
enjoy
take?
Bro, just because you guys are way behind us.
Okay, I think we can like stop. This, you can wait a long time. I promise you nothing will happen there, right? Okay, no, seriously, take the sugar off now. Not with your hands. Use I can smell salt.
Right? No, yeah, with sugar. Oh.
Stop.
Can make a tornado.
Right now, I'm putting.
I
Why are you ruining our wait.
Okay, so I think that this group is done and can move back to their seat because, boys, you need to complete the handout and turning in, right? Yes, I know, but I want you all to be scientists. But I would like you to understand what's going on. I will melt them and the one that melted first. Yes, okay, yes, the one that, because the other one didn't melt at all. Put the other one that does not, no, you were right, actually take it off. The one that does not melt would be an ion. Yes, very good. Okay, so do you all agree on this? Is that a nice little like exercise? Leah, do you like the smell of the sugar early in the morning? Did your husband? Okay, so now you can complete, you can also complete the handout. What happened? Okay, nothing happened.
Are you guys
Right,
doing this project?
Antonio? Okay, let's move back. Let's move back to our seats. Who else needs, did you want to do your own little thing? Are you observing, right? Well, we can do it again next class. So it's not melting? Okay. You want to come and, it's starting though. Look, it is starting. So you can see that, probably that this hot plate is not working great. The temperature is probably not going as high as the other ones, right? Because for them it was a very, it was really strong. But it's happening. You see that the sugar is starting to melt. It's changing color, right? right? It's turning like brown, right? So something's definitely happening. While the salt is just there, exactly the way it was before, right? And nothing's happening. And you can wait a while there, it will not melt, right? Because we can't reach those high temperatures. Okay. Can you please move back to your seat now? Did you see that there is a back side as well?
Why'd you do this, Mrs. Elliott?
I do it because I love you and I want you to become scientists. There you go. Ah, yes, let's turn it off if you don't mind. We can leave it on, like, we can leave it flat. That way, I'll press them. Let's wait until they cool down and then I'll press them. Okay?
Yeah, so we
Oh, we should go back. We should probably go back.
Okay. Oh, Jamie, could you show what's happening to the sugar, please?
It's boiling.
It's boiling. Okay, so we can now remove it because we don't wanna set the smoke alarm on, right? So we use tweezers, right, and remove it here. But have you noticed how quickly the sugar melted, changed color, burned, while the salt, look at it, nothing's happening, right? This is an ionic compound. This is a covalent / molecular compound.
Yeah.
That is why this is happening.
Yeah.
We are getting like so powerful because we can explain why things happen, right, Donald? Yes. Okay, move back now. I can leave this all there for a while, and then in a while we can come back and check. But I promise you that nothing will be happening to the salt, right, Paul? Okay. Thank you. Okay. For now, it did happen. Yeah. So I just put it here and then Okay. So complete the handout, and then we're gonna talk about the puzzle. I need to. Okay, let's leave this hot plate on, but let's then move the other ones off. Okay, good job. Was it fun? They put the smoke alarm. If this was in the cooking class, the smoke alarm would have gone off like 20 times. But here, because they do know that we do occasionally do smoke, right, in the lab. So I think we have a very high, there has to be a lot of smoke for the smoke alarm to go off. But that said, I might actually open this door. What do you think?
No.
Yes.
Yo, who left our groups on?
She did.
And I would reopen the other one. It's just that before there was that noise. Okay, are you trying to write incomplete sentences? Yes, okay.
Wait, what about the part where you could make a list of the elements? Like
A list of the elements. I did give you, right?
Yeah.
So what elements are in kitchen
Sodium
salt?
chloride.
Sodium and chlorine. So the elements are sodium and chlorine. When they add together in a compound, we call it sodium chloride, right? And the elements here are just carbon, hydrogen, and oxygen, okay? But they are a molecular / covalent compound. Can we open this door? Okay, so hopefully now the smoke is gonna. Oh, this is our puzzle that you are gonna start to work on now, okay? You cut, you have your little baggie. Yeah, you you need the list of cards. I'll talk about it briefly, okay? Cameron, I'm gonna get your hand out again. You are the chosen one.
You are the chosen one.
You are the chosen
Here.
one. Okay, complete it, and then turn it in, okay? So what happened there, guys?
Okay, so if we finish this, we turn it on.
Yeah, that please.
Turn it in over there.
Please.
Sounds good.
Did you write incomplete sentences? Huh?
Wait, what'd you write for?
Cooper,
What'd you write for?
Yeah, I did.
do you remember, right? So tell me this, please, and go back to your seat.
It smells bad over here.
I know, it's gonna go away soon. You guys kept bending the sugar, you don't wanna stop, right? Cause that was fun.
Because it's super
Happy
fun.
birthday, Tia. Are you turning what, 15 or 16? Whoa, sweet 16. You definitely deserve us to sing happy birthday.
I just turned 17.
Okay, yeah,
Let me up yet.
me too. Okay. Guys, ionic compound, right? Now, the next thing we are gonna do, Isaiah, was it fascinating to see that ionic compounds have very high melting points?
Yeah.
Yes, and covalent have pretty low
Covalent,
melting points?
Yeah.
Right, okay. So, do you see the activity ionic bonding puzzle? That you all have? Are we all done with our? Not really. Haley? Completed it. So you can turn that in. At least it will be one thing that you can in, right? Right? Auntie, you need to show me this?
Oh, no, I didn't.
Oh, okay, no, I hadn't liked before. Oh, I know, okay. So you're gonna come back with the test for the corrections at some point? Yes, it is complete. Super. Cameron. Let's see this one. No, I don't. Okay.
You're gonna ask me.
Me neither.
No.
Okay. Salt.
No. I thought she was innocent.
So, are we starting to do our part, guys? You need to really go back in your seats. I'll talk about it. Okay, so we will talk about covalent bonding for a long time, right, after today. So I'm not worried that you know everything about covalent. I just want you to understand real quickly what happens in a covalent bonding. What happens there is not that one atom loses the electron and becomes a cation and the other one gains the electron and becomes an anion. They share them, okay? They do share them, and so that they both have the octet. Do you see an example? H and Br, for example, right? You know that hydrogen has only one electron, right? And bromine has 7, right? And they both want to get to have 8, well, hydrogen will have 2, because in level 1 we can only fit 2, right? And so what do? They do share 2 electrons, right? So hydrogen will share this one, right? And bromine will share one of these 7 ones, okay? So it means that these electrons will be surrounding both the hydrogen and the bromine atom. That's what a covalent bond is, okay? So I do not have ions in there. I don't have a cation and an anion, right? I just have 2 atoms that get close and share valence electrons, okay? Start to think in these terms. We'll go over covalent for a long time, right? You know, it's gonna be our next. And like other example, this is another example of a molecule, PBr3, right? Like in the case of sugar, I'm not doing the whole formula. It would be very complex. They are 2 rings. Sugar is actually 2 rings with an oxygen bond in the middle. but the carbon and the hydrogens will be something like this, right? You see? Something like this, like the carbon will be bound to 4 hydrogens, right? Why? Because each hydrogen shares 1 electron, and each carbon also shares 1 electron. But you know that carbon has how many electrons? 6, technically, but 4 valence, right? So this way, they both have the octet, okay? I know this is like something that will take a bit of time, but this is what a covalent bonding is. Covalent molecular sharing, right? We share. Oh, I want to show you this picture, by the way, that I showed to all the honors and they really liked it. Now, don't focus on metallic. Guys, look up on the board. Look at the difference between ionic bonding and covalent bonding. Does that clarify it at all? Eh? No? So, the anion in the ionic bonding has got the bond, right? So the bond is the electron, you understand, right? It's chemistry, it's all about electrons, huh? So this is an ionic bond, right? So the electron now belongs to the anion, right? It's got the octet, it's happy. The cation is happy too because he got rid of that extra electron, right? That was like destabilizing it, right? But in a covalent bond, we all share, you see? We share the electrons, okay? So it's not like that we form a cation and an anion, but we just like share, okay? So that's like a visual dog-related like description of covalent and ionic bonding. But I think it gives you the idea, right? Huh? A little bit at least. I'll put it on the website, and then you can meditate upon it, okay? Oh, by the way, have you noticed that I assigned 2 textbook problems to next class? Page 207, number 14 and 15. Have you seen? Yes, I would write it down, or I put it on the website, of course. And now we have so much fun for the next 25 minutes. We're gonna do a puzzle, okay? Yes, you are gonna do a puzzle. Shh. Are you gonna have lots of fun doing puzzles? Eh? Okay. So, guys, do you all have activity ionic bonding puzzle? Or I stole your again, Cameron? I think I did, didn't I? The chosen one. Eh? I give you one more. Oh, by the way, did you pick up this handout too, right? It's like the naming. We'll probably go over it next class. But, okay, here you go.
Sweet.
So, ionic compounds. Hey, do we know this? A metal plus a non-metal, cation, anion, and so on and so forth. In this activity, you will create models of ionic compounds. These ionic compounds will then be named, and that's where things get a little bit tricky, and the electron dot diagrams drawn to show the electron formation. Now, so you can pick any cation and any anion, if you see what I mean. Like, Miss Savannah, can I use one of yours? Let's say what I'm getting here. Let's say I get out this, and this is lithium plus, right? 1. This is what? A cation and an anion. Answer! Yes, I like that. So now let's get an anion, right? So lithium is too easy. I changed my mind. I don't want lithium. I want something with a charge of +2. Or, yes, there you go. I get magnesium, right? Let's say I get magnesium. Now, the whole point here is that it has to be a rectangle, okay? So if I want a bond, and the other thing is that you always have to use 2 of the same thing. So I'm showing you how. Like, you clearly need like 2 anions there, right? To make a rectangle. You do, right? I don't want you to pick 1 bromine and 1 chlorine, right? This is not right. We are not picking 2 different anions, okay? Something like this will not happen. You will not find an MgBrCl compound, right? So you need to either pick 2 bromides or 2 chlorides. But do you see that you need 2 of them? because otherwise you don't make a rectangle. It's what we said before, right? The formula cannot be MgCl or MgBr. It has to be MgCl2. So hopefully this will be a visual way for you to understand that. In order to get a rectangle. What is a rectangle? Is a neutral ionic compound, right? It's neutral. This one has two positive charges. You see it's lost two electrons? Do you see that? It's lost and now it's doubly positively charged. These ones have gained an electron, right? So now they are negatively charged. But what I want to say is that you need to use only two different kind of atoms, not three, okay? You use magnesium or whatever, or lithium or calcium, and then you use either two bromides or two chlorides, okay? Which you should have. And you can also like work with your neighbor, right? And then, so you have the first part is like, okay, this stuff you all know. What is required for an ionic compound to form, you know. Can an ionic compound consist of a cation or an ion bond? No, right? And you know why not. Because positive doesn't attract positive and negative doesn't attract negative, right? Also, research and show the formation of 3 ionic compounds that you use in your everyday life. First of all, you can use your lovely 24 hours Google connecting devices, but one of them is salt, right? NaCl, pretty obviously salt. You can find many other ionic compounds in our everyday life, right? Here, this is what you're gonna do. You're gonna complete this table and do the puzzle, okay? So you're gonna write the cation name, how many cations do you need, the anion name, how many anions do you need, what the chemical formula is, what the chemical name is, which is gonna be, okay, ide, remember, apart from when we use polyatomics, and the electron dot diagram. Remember that usually the cation is either 1 or 2 dots, right? The anion is either 7 or 6 or 5, and then, you know, they just like, one gets rid of the electron, the other one gains the electron, and they're both happy and attracted to each other very strongly, huh? Okay, so you want to start to do this? I don't expect you to complete it, the whole table, but you will do this for homework along with those 2 problems and bring it back next time. Also, please bring back your little baggie with all our little anions and cations. Eh? Will you bring back your little baggie?
I will.
You, Donald, you haven't put them in your bag. Now you're using it, but you can put your name on the little. Oh, good job. Okay, are we starting then? Huh? So you need always to pick something which is positively charged and something that is negatively charged, right?